Hello, and welcome to the first episode of Diana's Makerspace. In this space, I like to talk about different projects that are being done, different vendors, and also talk about different videos I found of various people. A little bit about myself. I'm a retired medical researcher, executive at the Society for Computer Simulation from 1992 to 99, medical researcher 1989 to 2005, and entrepreneur consultant from 1984 up to 2005 and semi-retired from 2005 onward. I do work on gig projects. I recently had an article published in 2600 magazine talking about how I linked a Fax Star Plus to an HP 9000 to make it easy to transfer medical files and then transfer it over Ethernet so that basically I could save a drive from driving from downtown Milwaukee. From the medical research site, Milwaukee County Medical Research Site to the downtown site, which was then at 17th in Wisconsin. Also made it easier so everyone could get their results very fast and quickly, rather than having to put it on floppy disk. The thing about that time is we used what was called an IEEE interface, which the GPIO interface reminds me of that. And my hobby is retro computing projects as well as Arduino, Raspberry Pi. And I do like to support various vendors as Amazon, Microchip, DigiKey, Temu, and Alibaba. Due to my budget, I try to select the best products at the best price. A hint to DigiKey and Microchip. It'd be nice if you had a reduced shipping program, a reduced vendor program like Harbor Freight does, Alibaba, where you just pay so much a year, or like Amazon, so much a month, you get reduced shipping. Because for me, the $17 shipping fees really kill me. Also, I support Electronics Express. Same thing, if you have like a member program or something to help us basically who don't have as much of an income. Also to help, people buy from you a lot. Just sort of way to work on the shipping costs, because it does kill us, the $17, even though if we just do a $10 order, $20 order like that though. So, well, I'd like to show you some projects that I've been doing, and that. This is a copy of the project that I saw on Ben Eder's video. This is for a 28 pin chip. Normally I use an AT28C64 for my retro projects. And what I did, I modified a few things from his original design. I added this LED lamp. So basically you don't have to have a bunch of LEDs. It automatically has resistance in there. So basically you don't have to worry about adding resistors. And then I added an on-off toggle switch because I feel the same way about trying to take the chip out hot like that though. So you can put it on and off like that though. And what I did is I replaced the dip switches, because his video was made 7 years ago, and I replaced it with basically spring-loaded switches. So you just go like this, you can touch, and also can set. It's the same type of switch that's used on many common appliances. I did like the design that he did, where basically he took keeping the wires on one side, like for this is D0, D7, A0, A7. And what I did is I used the resistor network to do most of the power. So there's one power plug here, then there's another power plug for D7, because this resistor network I got was an 8-pin, and same thing for A7. Also, what I like though too is basically how he has a resistor that goes on this side to get the transient voltage, so it goes down to ground. What I did though is I did like his idea about how to do the timing with the RC circuit. I didn't have a 1 nanofarad capacity, so I had 93 picofarad, which is a 0.1 farad. And then what I used was I used a 5K resistor, so it makes it basically a 453 nanosecond delay rather than so it fits within the 100 nanosecond to 1000 nanosecond delay. And the chip bed, I like a chip bed because that way it's easier for me to put the chips in and out. And I noticed that the AT28C will work with this, the Hitachi HM6264 will work with this, and some other chip variants will work with this as well. So with some of these, this is one of the projects I like. And when I do some of the projects, one product that I did buy basically from Temu, this is the FN First 3-in-1 oscilloscope. And the nice thing is what I like about buying from Temu and from Alibaba is that they have Afterpay. So that basically, for me, it makes I can pay it off in 6 weeks. I make a payment every 2 weeks like that though, and also what happens when you get the first payment in, they ship it to you. So basically, it's a lot different than other firms, and also there's no credit check required. So basically, if you have issues with depending on what your issues are with credit or anything like that though, you can do it pretty easy. But the main thing is it's very easy to get stuff and Amazon is starting to shift over to different payment methods. They still have a firm which I haven't used the firm because I haven't been able to get a purchase approved with the firm, but I like Afterpay, and I think I also use ZipPay as well like that though, because they ship right away and basically it's very easy. So and this oscilloscope, basically it's a 3-in-1, but it's even more than that. Basically, you have a sound generator, you have a single channel oscilloscope, basically function generator, component tester, diode resistors. Like this afternoon, I actually used it to separate my resistors that I had used and took out the packaging, so I put in different envelopes. And you have multiple features. It runs off a battery. You can plug it in. It has a standard USB port. I mean, this is a good go-to. Actually, I'm planning to buy a second one next month for my projects. Now, one project I like that I'm working on is basically this is the CPM. I shouldn't say CPM, but basically, this is the retro project. And with the retro project, basically, the retro project is based upon this is a special a Z80 computer board. You can see it has a switch register, has a manual clock button, a manual reset button. But I'm going to use the oscilloscope to add as a function generator. So basically, and then a status light. Also, it has 2 types of I/O ports. It has a multi-input and output port and a latched output port. So basically, this you can send latch signals, or you could use this for multi-input output. That's how this would read the switch register. In addition, it uses an AT28C64 EEPROM. And what I'm planning to do is add an 8255 and a 6850 to allow for retro use for different types of equipment, like that use a DS9, DS25, and other things. And what happens though, the reason for that is because there's a lot of different types of test equipment, other equipment that uses an IEEE 488 interface, and the GPIO is perfect for interface with that. But also, if you have an 8255 chip and an 8250 and a 6850 chip, you can use that, because when you can use this. And also, I'm trying to link this with Arduino and a 68000, so to make it so completely current to retro mode. And even I made a board which is an Arduino 8255 I/O controller board and an 8255 6850 board, so that basically you can do different things with it. You can see what you can do with it. Also can interface with different types of devices and other things. Now, I like to experiment with different things, but when I do experiment with different things, one thing I always like to do is basically just have a little bit of have a test board. Like for example, I'm working with this is a common cathode display, which means that basically the ground is connected up here on top, and then basically it is so the outputs are active high. But I'm using a 7447 chip with a switch register, so I need to convert the output active high, active low, outputs active high. So here I'm using a 7400 chip, and a 7404 is to invert the signal. The 7400 basically is a NAND chip, so you hook two inputs in, inverts it in, and then basically this links into this. I'm planning to order a 7448 chip, which works with a common cathode because that's active high. So the thing to remember about with the 7447, the 7447 chip is made to work with the common anode chip. So the chip is powered, and then what happens with the active low provides a ground that lights the segment. Now the 7448 works with the common cathode chip, which means the chip is connected to ground, so the active high inputs provide the circuit that go the other way, basically from anode to cathode. It's always anode to cathode, but the active high circuits are actually the anodes in the 7448, where the active low circuits are actually the cathode in the 7447. The reason for using a test module is basically before I add it to my other modules, I like to have the confidence to know that everything works and that I've done all the wiring properly. Now, a project that I think is interesting with today's technology, even basically on technology that existed even during when I was in school in the 80s, like that. This is a supercomputer, miniaturized supercomputer processor board using BitSight processors. This is 47481s made by TI. Plus the look at January 7482 made by TI. There have been many applications where these have been linked together. There's one university that did this in Germany. There's others. And then basically it has registered chips. This is one registered chip, 6850. The 16-bit registered chip, 16-bit registered 16-bit registered chip, 16-bit registered chip, 16. So what happens? It has a register and a B register for the inputs, a C register for the outputs, and then an 8-bit memory chip for the instruction set. And the instruction set is basically as an extendable instruction set, because the first mode instruction set uses the BitSight processors, while the other 7 modes you can use it to hook up to any type of processing you want, and that's the reason why there's a multiplexer right here. So basically the processor is basically the first 3 bits of the processor are the execution modes. Execution mode 0 is this. Execution mode 1 through 7 is basically the external, and you can have 32 instructions per execution mode. The other thing is I added a switch register, so you can actually preload these either way, and you can hook up an interface to preload these before you use this. So if you're using like an Arduino or something, you could use this as an auxiliary board. And just for fun, I added a switch register, so another switch register for the clock, so you can actually use it as instructional. It has a potentiometer, you can move it, and you can set the speed at which you use it. So you can actually use it as a teaching mode to teach instruction supercomputer design. The biggest thing about this is this will all run on a 9-volt battery. I'm using when I add a 7805 buck converter, it'll convert this over to 9 volts, and then 5 volts, and then basically this will all run. It's a 1024-bit word size, and it has a potential of 560 megaflops, all on this small size board. Now, when you think of a supercomputer, you think of a Cray 1, Cray 2. I mean, at the time with the chips that they developed, these were big things and everything else. And now this is completely, it's amazing. It's miniaturized, what I call, down to a small pizza board. I think of this as making a pizza like this. This is the sausage. This is mushrooms, and this is the different types of cheeses. So I make these. I think of making pizza because I do love pizza, cheese, sausage, and mushrooms. And then I order from Delangle's Pizza. We've always ordered from, even when I lived in Kenosha, we ordered from Delangle's, as well as also Villa de Carlo Pizza when we lived in Kenosha too. Wonderful, and so I always like that. And so when I think of these, I design these like a pizza board. But 560 kiloflops, basically 9-volt battery, a portable supercomputer. And then what happens when I convert this over to a PCB board, if you can imagine this being down to the size of maybe this, or maybe even this, when I convert this down to a PCB board. So when you think of different types of computers, when you think of different types of projects, it's interesting how basically just experiment, try different things, and do other things. Some people I recommend to learn on this is basically like Ben Ita's website for the first demonstration I showed where I followed his ideas of developing a simple E-chip board. And the part of me says for this is for my projects, I want to do something that's basically that way I also can use this as an E-chip tester. And I've made my own Arduino programmers using the MCP 2317 where I used a dynamic mappable sequence. And the other podcast I like is Becky Stern's podcast. I've learned a lot from her podcast, and even with my apartment size, about how you can keep a workshop in the apartment, and basically just have it. Just have it do it, so basically you can have a good space. And also DroneBot workshop with Bill. I've learned a lot about different types of things with Arduino and how to hook buck converters and everything, gain confidence. All three I recommend highly, and I'll put links in this so that you can see all these and follow these. Also, the other shout I like to do is to NerdForge. I like the couple that works the projects. But one thing I'd like to shout out to them is I like the one you did with the 1-cup coffee maker. I was just wondering, is that available for purchase? Because I live in the United States. Are you able to make it so it can work on US voltage? And I'm interested if you make one that's fully assembled like that though. Because if you do, I'd be interested in buying it. I love coffee myself, and I would like a perfect 1-cup coffee maker. I just put the beans in it, grinds it up, and everything else. This would be perfect for me. So if you can, let me know. For comments, just post things in the YouTube comments, or the other thing is I like comments sent to x@Diana1A, because that way it makes it easier both ways for me to see it. Well, let me know what you think, and I'll have more podcasts in the future. This has been Diana's Makerspace, and I thank you for watching.